Polymer piping systems are in wide use today, but are they better, worse, or just different? Let's dive a little deeper. I'm Mark, a senior forensic engineer at Nederveld. Today we're going to talk about CPVC piping systems. That first C is chlorinated, which increases the flexibility, chemical resistance, and thermal resistance of the pipe itself. It's a material that is widely used in piping systems that is easier to install and lighter than copper and provides better longevity than PVC systems. It's used in domestic water systems in mobile and manufactured homes and some tract homes, as well as fire suppression, both residentially and commercially. CPVC is a solvent welded system that has a few installation issues to consider. First, it uses only manufacturer-listed one-part solvents that solvate and bond the mating components together. As such, the surfaces must be clean and free of contaminants. They must also be held rigidly until the weld has set. Thermal expansion, accomplished with offsets and loops, is imperative, especially in high thermal change installations, such as attics for fire suppression. Supports for expansion and contraction are also important. Protecting the pipe from sunlight is another issue that must be considered during the installation phase. Documentation of locations and distances related to supports and change in directions are important. The fluid and makeup of the water supply should be documented as well. Installation-related issues are typically improper thermal expansion, improper solvent, aged solvent, or installation when it is too cold or too hot. We also have abuse and external forces. Impacts will fracture these pipes, so they are not suitable for installation in locations exposed to such characteristics. Age, wear, and maintenance is not really a problem with this material, but freeze-related failures are common and usually involve an improper use or operation of a fire suppression system. Improper antifreeze solutions are also a big one for fire suppression systems. In our recent reports on CPVC systems, installation and utilization issues are the overwhelming cause of failures that we see. Freeze failures are also common, but is a system where manufacturing material defects are extremely rare. Since most common failures are pipe or fitting fractures, the main procedure is to classify the fracture. They may manifest as a bending, an internal pressure, or propagating crevice cleavage fractures. Each has specific features which we often refer to as fracture morphology, or to the layperson, how it looks. The fracture morphology is then associated with the installation geometry, practices, and utilization. In most cases with CPVC, it is a pretty straightforward process to be able to classify the failure mode. It is often damaged due to installation or utilization issues. For that reason, those parties are important to get placed on notice of a failure. If the part arrives undocumented or after significant mishandling, we may have insufficient information to determine the cause of failure. So remember, proper documentation and collection of evidence is important. Please feel free to check out our other videos in this series.